Let's continue on our example. We are asked to find the magnitude and direction of the displacement vector. We are given that vector RA has a magnitude of 6 and vector RB has a magnitude of 4, and the angle between RA and RB is 60 degrees. By the way, the direction of the displacement vector, we have to apply it in terms of angle between the displacement vector and the vector RB. So what I'm showing you here is, this is vector RB, right? I kind of translate it here with a dashed line so that you know that it's equivalent to RB. So the angle is this one, gamma. It's the angle between the displacement vector and the vector RB. So this is what we have to find as well. So what do we know so far? We know this, right, from addition lesson, that if C is equal to A plus B, and we know about A, we know everything about B, like we know the magnitude of A and B and how they orient with each other. We can find the magnitude of C using this formula, and we can find the direction of C in terms of beta, which is the angle between C and A. We know this. We can use this to solve this problem if we translate it into an addition problem. And we can do this by absorbing the minus sign into RA. So essentially, we are going to treat it like this. Delta RBA is going to be equal to RB plus a whole vector, which is minus RA. So let's start reformulating the problem in terms of the addition form that we are trying to do. Let's look at minus RA first. We know that this is RA. It's as long as 6 units and its head is there. For minus RA, what we have to do is we have to flip the direction, right? So the head of minus RA is not going to be there. It's going to be here, like this. So this whole vector represented graphically here is minus RA. This whole thing is minus RA. Its magnitude is still 6. The second one, RB, where would it be? It remains the same. So what I'm going to do is I'm going to translate its tail so that it's attached to the tail of minus RA, like so. When I translate it, the magnitude remains the same as 4. What about this guy? Where would it be in the new picture? What I have to do here is I just need to continue drawing this line a little bit with a dashed line. And this is the same angle, right? You can see it graphically. It's the same angle. So this is 60 degrees. Now what you're going to have is a parallelogram of vector addition that we covered before, like that. The dashed lines that you see here is when I translate this minus RA vector over here. This one is when I translate this RB vector over there. You have an addition parallelogram, right? But what essentially is happening is that if you do this addition, you are connecting, or let's say that you start with RB, you are attaching the tail of minus RA, so you have to draw from the tail to head, and therefore this is the vector delta RBA that you are looking for. After reformulating into an addition form, we are ready to calculate the magnitude in the next video. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.